The purpose of this project is to reveal the conductivity of snow. Conductivity is the ability of a solution to transfer or conduct electric current. Conductivity will determine the unknown ion concentrations of the snow samples. The unit of measurement that will be used is microsiemens per centimeter. Especially during the winter time, high concentrations of ions are present in certain areas such as stairs, sidewalks, and roads due to an increase in usage of salt to melt the ice, avoiding accidents from occurring. Understanding the concentrations of ions is significant if the concentrations of ions are too high. In this case, if the chloride ion concentration is too high, there will be an increase in corrosion of water, damaging the physiology of natural environments. To find the conductivity of the snow samples, a standard of conductivity was created by using 400 milliliters of distilled water and adding 0.1 grams of sodium chloride, also known as table salt, then stirring for 1 minute to dissolve the solvent in the solution. The solution was then left for 2 minutes to allow the solution to stabilize. The conductivity sensor is then placed in the beaker to record the conductivity level. This process is repeated until 1.8 grams of salt is recorded. Once all the data was recorded, a line graph was then created to obtain the formula and coefficient of the standard curve. A total of 11 snow samples and 1 Poultney River sample were acquired to measure the conductivity. All samples were heated and stirred on a hot plate using a stir rod to measure the conductivity of the samples. To find accurate measurements, the temperature probe was used to attain a temperature of 25 degrees Celsius. When all samples reached 25 degrees Celsius, then the conductivity was measured. Once the conductivity of all samples were acquired, using the formula obtained from the standard curve, the ion concentrations were then found and recorded on the data table of snow samples. In the standard curve, we can observe that the line flattens at the top after 0.8 grams because the ion concentrations were too high for the conductivity probe to measure. Therefore, the equation and coefficient were obtained from the first 6 points of the standard curve. From our results, we can observe from the bar graph created that the locations with the highest ion concentrations were the locations containing the most salt, which were the Ackley Stairs by the chemistry lab and the Withy front steps, containing about 0.7 to 2 grams. The Poultney River had a low concentration of ions, which is relatively good news. The locations with visible salt present were the samples with the highest conductivity, and the samples with no visible salt had the lowest conductivity, which was St. Raphael's Church. Because the conductivity probe has a limit of measurement, accurate results could not be given of the samples with high ion concentrations.